Continuing with 10.4, we are going to look at this thing called the dot product, as well as finding angles between two vectors. So the dot product, we are essentially taking two vectors and multiplying them together. But instead of getting a vector, we are going to get a scalar value, so just another number. And that formula, we are going to take the product of our corresponding horizontal values and the product of our corresponding vertical values for each vector and add them together. The second formula that we're going to look at today, finding that angle between two vectors, cosine of that angle is going to take the dot formula, and we are going to divide it by the two magnitudes of each vector. So what does the application of these formulas look like? Well, let's see. For this first example, it's telling us to find the direction or the angle of vector AB with respect to the positive x-axis in degrees, given that A is the point 35 and B is the point -32. Okay, so let me go ahead and just start with drawing in a set of axes. We have the point A at 3,5 and the point B at -3,2. So A and B, and this is going to be my vector there. It's asking us to find the angle between that vector with respect to the positive x-axis. Well, let's go ahead and move this vector so that we can relate it to the x-axis in a more visually pleasing way. So I'm going to move this vector. We are always going to have our initial point start at the origin. So A is going to move down to 0, 0. If I moved A to the right, or excuse me, to the left 3 and down 5, I also need to move B the same direction. So B, we're going to move somewhere over here. And this point is going to end up being -6, -3. So our new vector, well, not our new vector, just our moved vector, is at this location. Okay, so we are looking for this angle now. Well, how have we found that angle in the past? Using a little bit of trig. So if I draw in a right triangle here and I call this central angle theta, we can say that the tangent of theta should be equal to, if this side is -3 and this is -6, -3 over -6. And when I take the arctangent of that theta, we should get approximately 26.57 degrees. Now be careful because we're not done. This angle is in the third quadrant, so we need to add 180 degrees to theta, and we should get our final answer of 206.57 degrees. For a problem like number 11, it's telling us to find the magnitude of vector AB plus vector CB, given these 3 points. It tells us to do it geometrically, so we're going to do that first, and then I'll show you how to confirm that algebraically. So, because we are going to do this geometrically, it will be easiest to start off with our coordinate plane. So our first vector that we're given is a B. So A is the point -4, 1. around there. And B is the 0.02. So we have that vector. And then we have CB to -3. So what we need to do is we need to add these two vectors together. Well, quick side note, remember that in order to add vectors together, they must either be head to tail or they must have the same initial points. That way we can do the parallelogram law. So because our vectors AB and CB are neither of these right now, let's go ahead and make it into one of these. So I'm going to choose to make this problem into a head to tail so that we can find the addition of these two vectors. So what I'm going to do is I'm going to take vector AB and I'm going to move it so that point B is the same as point C. Between B to A, I need to go down 1 and to the left 4. So at point C, I'm going to go down 1 and to the left 4. And so I have now moved my vector AB. And remember the reason that we did that is so now that these two vectors are head to tail, we can add them. And their addition is going to be that new vector there. So now that we have that new vector, we can take the magnitude of it. Remember the magnitude, I just need to see what the horizontal and vertical distance is from start to end. So horizontally, we moved 2 units, and vertically, we moved 6 units. So our magnitude is going to end up being the square root of 2 squared plus 6 squared. And that should give us the square root of 40, which reduces to 2 root 10. So that's doing a problem like this geometrically. Algebraically, if we were to do this, what we would do is we would find vector AB in component form. And so remember to do that, I'm going to take the end point, that B, so my 0 and my 2, and I'm going to subtract my A point, -4 and 1. And so my AB vector is going to end up being 4, 1. We can do the same thing for the CB vector. So I'm going to take those B values and subtract C values. And so CB is going to be the vector -2, 5. Now I'm going to take these two vectors and add them together. So that's simply going to look like 4 plus a -2 and 1 plus 5. And so this vector is going to be 2, 6. And when I take the magnitude of that, that is simply going to be the square root of my I values plus the square of my j values. And lo and behold, that is what we just did. That simplifies to 2 root 10. Problem 12, we are going to go ahead and review some of the algebraic stuff we did yesterday, as well as work with the dot product. So for part A, we are just doing vector v plus vector w. So remember, we are just going to add those components and get this new vector. So that new vector should be 5, negative 1. For part B, we are going to do order of operations. So we are going to take v plus w, and we are going to apply the dot product to that vector and our u vector. So since part A already found v plus w for us, we are going to say that we are going to take the dot product of negative 4, 5, that u, and our answer from A, 5, negative 1. So the dot product, we are going to take the horizontal components, so the negative 4 and 5, and multiply them. Add that to the product of the vertical components. So we get negative 20 minus 5, and our dot product is just negative 25. For part C, now we have something that's a little bit more complex. When you have something like this, do the dot product first, and then we are going to add those two answers together. So the dot product of u and v, we are going to take negative 4 times 3 and add 5 times 4. Whatever that answer is, we are going to add it to the dot product of u and w. So that is going to be negative 4 and 2 plus 5 and negative 5. So we end up getting negative 12 plus 20 plus the quantity of negative 8 minus 25. That negative 12 plus 20 gives me 8. And the negative 8 minus 25 gives me negative 33. And so 8 minus 33 gives me negative 25. So what part C just showed us was that the dot product is distributive. So what that means is if you look back to part B, if I took u and distributed that with the dot product inside of my parentheses, we would have gotten what part C was asking us to do. And as we have just shown, both ways do give you the same answer. Moving on to a problem like 13, it's telling us if theta is the angle between vector A and B, and vector A is 5, 6, and vector B is negative 3, negative 7, find theta. So remember that we have the formula cosine of theta is equal to the dot product of two vectors, in this case A and B, divided by the magnitude of each vector. So what we can do is first finding the dot product between A and B. Well, that's going to be 5 times negative 3 plus 6 times negative 7 all over. When we look for the magnitude of A, square root of 5 squared plus 6 squared times the square root of negative 3 squared plus negative 7 squared. And we can go ahead and simplify this. So we get negative 15 minus 42 all over the square root of 61 times the square root of 58. And so we can go ahead and take the arc cosine. Let me go ahead and simplify this actually a little bit more. So negative 57 over the square root of 61 square root of 58. Remember that this is equal to cosine of theta. So I can take the arc sine of this entire fraction, arc cosine, and we can plug that into our calculator and get that theta is equal to 163.4 degrees. Similarly to a problem like that is a problem like 14, where we need to find cosine of theta between these two given vectors. So again, same equation, cosine theta equals the dot product between these two things. So 2 times -5 plus 5 times 2 over their magnitudes. So if I take the square root of 2 squared plus 5 squared times the square root of -5 squared plus 2 squared, this ends up simplifying to 0 over the square root of 29 times the square root of 29. So this whole thing is just 0. So we found cosine of theta to equal 0. Now let's talk about this really quickly. When cosine of theta is 0, that's telling me that theta is equal to 90 degrees. So what we can say is, if theta is 90 degrees, then the dot product is 0. To go along with that, we can also say that if the dot product is 0, then theta equals 90 degrees. If you go on to take more advanced math classes, name that you will hear about when theta is 90 degrees, we are going to say that these vectors are orthogonal. And what orthogonal means is a fancy name for perpendicular.